Why can't you tickle yourself? Try something for me. Take your own finger and run it along the inside of your arm or the sole of your foot, exactly the way a friend would if they were trying to make you laugh. Same pressure, same motion, same ticklish spot you've known since childhood. Nothing happens. Now picture someone else doing the very same thing, without warning. You'd flinch. You'd laugh. You might even fall out of your chair. Same touch. Same nerve endings. Same body. And yet one version does nothing at all, while the other reduces you to helpless laughter. For centuries, this was simply accepted as one of life's small, forgettable oddities. It isn't. It's a window into one of the most elegant tricks your brain performs every single second of your life, almost entirely without your permission. To understand why, we first need to understand what tickling actually is, because it is not one sensation, it's two. The first is called nismesis. It's the light, feathery kind of tickle, a fly landing on your skin, a hair brushing your neck. It doesn't make you laugh. It makes you want to scratch. Even insects and animals seem to feel this one. Rats do. Even some reptiles do. The second is gargalesis. This is the laughing kind, the kind that comes from a firm, targeted touch to specific parts of the body, and it appears to belong almost exclusively to creatures with complex social lives. Humans have it. Chimpanzees have it. Rats, surprisingly, have it too. And researchers can actually hear them laugh, in a register far too high for the human ear. It's this second kind, gargalesis, the laughing kind, that you cannot produce in yourself. And the reason comes down to a single, quietly remarkable feature of the human brain, called an efference copy. Here is the simplest way to think about it. Every time your brain sends a command to move a part of your body, it doesn't just send that command once. It sends a copy of it to another part of the brain, specifically a region called the cerebellum, tucked at the base of your skull. This second copy acts like an advance warning. It tells the rest of your nervous system, in effect, this sensation you're about to feel is coming from us. We already know about it. There is nothing here to react to. Your brain, in other words, is constantly predicting the exact sensory consequences of your own actions, and then quietly canceling them out before they ever reach your conscious awareness. It is the same reason you don't notice the feeling of your own clothes against your skin after the first few seconds. The same reason you can't surprise yourself by clapping your own hands. And the same reason your own touch, no matter how precisely aimed, never carries the jolt of an unexpected one. This wasn't just theorized. It was tested, memorably, in 1998, at University College London, by a neuroscientist named Sarah Jane Blakemore. She built a simple machine. Volunteers would move a lever with one hand, and that lever would control a soft foam pad that brushed against their other palm. When the pad touched them at the exact moment they moved the lever, they felt almost nothing. It was their own action, perfectly predicted. But then Blakemore introduced a delay, a fraction of a second between the movement and the touch. And something remarkable happened. As that delay grew, even by a tenth of a second, participants began to rate the sensation as more and more ticklish, more and more like a touch from someone else. By the time the delay reached about a third of a second, the machine felt almost entirely foreign to them, even though they were the ones operating it the whole time. Your brain, it turns out, isn't just checking whether a sensation came from your own body. It's running a precise, split-second timing calculation. The moment prediction and sensation stop lining up exactly, the cancellation fails, and the tickle gets through. It's worth asking why the brain would bother building something this intricate in the first place. The answer has to do with survival, not amusement. A nervous system that reacted, in full, to every sensation your own body produces, every footstep, every swallow, every brush of your own hand against your side while you slept, would be a nervous system permanently overwhelmed with noise. It would have no way to tell the difference between the rustle of your own shirt and the far more urgent rustle of something moving toward you in the dark. Efference copy is, in effect, a filter. It lets the brain say, quietly and constantly, "This one's ours, ignore it," so that its full attention remains free for the one sensation that actually matters. The one that comes from somewhere else. which makes the exceptions to this rule. Some of the most quietly fascinating findings in modern neuroscience. Researchers have found that people experiencing certain symptoms of schizophrenia, specifically what are called passivity experiences, the unsettling sense that one's own thoughts or actions are being controlled by an outside force, can sometimes tickle themselves. Their efference copy system, the very mechanism that should be labeling their own actions as their own, appears to misfire. The prediction and the sensation no longer feel connected, and so a touch that should feel unmistakably self-generated instead feels like it's coming from somewhere else entirely, because, as far as that part of the brain is concerned, it is. It's a strange kind of proof by absence. The only way we fully appreciate how completely this system works in a healthy brain is by studying, with great care and compassion, what happens to a person's sense of self when it doesn't. And there's a gentler side to this story too. Gargalesis, the laughing tickle, shows up almost exclusively in the context of trust. Parents tickle infants. Infants shriek with a particular, unmistakable kind of delighted laughter, one that shows up in the very first months of life, long before a baby understands language or jokes. Primates groom and tickle their young for the exact same reason. It seems to be, at its core, a rehearsal for a very specific kind of vulnerability, allowing another creature, one you trust completely, to touch you in a way that would otherwise put your whole body on alert. That's arguably why a stranger's attempt to tickle you rarely lands the same way. It isn't really about the touch itself. It never was. It's about who, exactly, is on the other end of it. So the next time you try, and fail, to tickle yourself, know that you're not missing some strange, mysterious talent that other people simply have, and you don't. You're witnessing your own brain succeed, spectacularly, at the very thing it was built to do. Telling the difference, in a fraction of a second, between the world acting on you and you acting on yourself. It is one of the quiet miracles running underneath the surface of an ordinary day. And most of the time, we never even notice it's there. If this changed the way you think about your own mind, hit subscribe. The Effect Files digs up the science and the psychology, hiding behind the small, strange moments that quietly shape every one of us.